Real-time feedback into the behavior of your distributed systems and observing changes, exceptions, errors in real time allows you to not only experiment with confidence, but respond instantly to get things working again.
Hello, Chaos folks. I'm so delighted to be part of the Conf42 Chaos Engineering 2022 as speaker with such great speakers. Today I will be presenting to you, as you all know, Chaos Engineering alongside LitmusChaos and Jenkins. It's like a Rex, what I have done with my clients' talent to improve the resilience of its app before promoting it to production and making it easier to developers and SRE to execute chaos. I'll be explaining it in a deep dive in a bit. I'm sure that also that you have already seen many great talks about today about the why and when to do chaos engineering, but I will be focusing on the how today. So it will be also shown by a demo. Before that, I would like to present myself. I'm Akram Riahi. I'm an SRE and a chaos engineering at WeScale. I'm also an author of several blog posts related to the chaos engineering and Litmus, and also I'm I'm an organizer of the Chaos Week, which is like a week-long chaos engineering fest with great speakers such as Oman Bukarov, Litmus, Uranino, Jason also for Gremlin. There are other many chaos engineering folks also who has been included in the Chaos Week. This event aims at Cloud Native community in France, and I'm also part of the Paris Chaos Engineering Meetup. I've also participated in the Chaos Carnival recently as a speaker. Who we are. So we are WeScale, that has been created in 2015. It's already more than 50 experts whose mission is to help you become cloud native. We help you also think, build and master your cloud native architecture, continuously adapting to your maturity. What sets us apart is our high level of expertise and personalized support on cloud native technologies, with a conviction that know-how only has value if it is already shared. That's why we are trying to write several blogs and do some meetups, etc. We are also a member of the CNCF and partnership with HashiCorp, but also with AWS and GCP. In a few minutes, we will have like a presentation of our menu for today. We will have like an introduction. Then we are going to see together how is chaos engineering easier with Litmus for developers and SRE to improve the app resilience. We will also discover the harmony between LitmusChaos, Jenkins and Slack. We will deep dive into that via an amazing demo at the end. With my clients, it's always hard to look for a solution to test and improve our application resilience before promoting it to production. And also it's hard to ensure that it will be highly resilient, and we are not going to get some incident and in the morning and the very morning, and we are not going to get surprised. Today we are faced by two major choices. Either we can create scripts and add some tests that can take a lot of time and investment and also a lot of consultants also. Or we can go to the chaos engineering discipline with scientific approach based on hypothesis and experimentation. But here the question, is it difficult? Do we have enough knowledge to do chaos? how can we deal with it in a daily basis, knowing that we are pushing a lot of code that has to be tested in terms of resilience? And also, we are going to face this question: can we make it easier for developers to do that? If we say, okay, for example, if you are going to say, okay, we can do chaos, but is it going to be easier for developers and SRE to do that? Well, I'm very certain that this answer is yes. But how? How case engineering is easier? Now, the delivery process has more steps, from dev all the way to the CI/CD. Each time the developer pushes code, it will be tested by a classical approach called QA tests, with all type of tests that looks for things we all know. It means that we are going to test things that we already know, but we don't go on to see what we can't expect, and we can't the unknowns, in other words. But we have also the right to get surprised sometime by a problem we don't know and we don't expect also, in order to improve the app resilience. For that reason, we have also to enable developers in order to inject chaos in their DevOps pipeline as often as they want. So today our talk will be around this enablement and how they can easily inject chaos via sample push or a pull request. To do that, we are going to present the environment. So our environment will be based on AWS and Kubernetes for the infrastructure, and AWS as a cloud provider, and Kubernetes as a container orchestrator. We'll have also Jenkins for the CI/CD part. We'll have Terraform for the infra configuration, and we also have Slack for the notification and communication, notification, alerting, and communication. As we all know that communication in chaos engineering is very important in order to alert people, in order to make people knowing that we are going to inject chaos, and so they don't get surprised, and also that helps us to collaborate together in order to improve the app resilience and to improve the system results. In other words, we'll have also GitHub for our code SCM or code management. We also, for the chaos injection, we will use our famous framework, which is LitmusChaos. So what is LitmusChaos? LitmusChaos is like an open source framework used for chaos engineering, and which helps Kubernetes SREs and developers to practice it in a Kubernetes native way. Litmus was in CNCF sandbox, and now it's in incubation because of its great community and the big community behind it that supports chaos Litmus, and make it continue and trying to improve it continuously. And you can find it in GitHub repo LitmusChaos. Litmus, now it is in version 2.6, 2.6.0. Well, the importance of Litmus is like behind the chaos experiment that provides. So Litmus provides a lot of chaos experiments in Kubernetes and AWS, etc. It will help us inject various scenarios such as CPU hogging, memory hogging that target the resources, and we can also have some experiments that target, for example, network, such as network latency, for example. And this is in the pod, for example, the radius. We can enlarge the radius in order to attack, for example, nodes. These experiments are available in like Chaos Hub that group all these chaos experiments. This chaos experiment can be organized and executed, or in another word, orchestrated within a chaos workflow. So here's the question: what is the chaos workflow? A chaos workflow is like a set of different operation, or we can call it chaos experiment, coupled together to achieve like a desired chaos impact on a Kubernetes cluster. Well, the importance of this chaos workflow is like it is very useful in automating a series of like preconditioning steps or action which is necessary to be performed before triggering the chaos injection. And the chaos workflow can also be used to perform different operations parallelly to achieve a desired chaos injection scenarios. For example, so I see that my application is very affected by the CPU and memory. So it means that if I, For example, I want to test these two, the impact of the update or the injection of chaos injection on these two resources. These two resources. So I can go for a chaos workflow, for example, and create, for example, a workflow with two experiments, CPU hogging and memory hogging, and make it run parallelly. So, and for example, I have noticed that lately I have gotten many network latency on this app, so I would like to see that and to make it, for example, randomly on the different also dependencies. So I can create workflow that has, for example, two experimentation running in parallel, CPU hogging, memory hogging, and then going in serial with network latency. This chaos workflow can be, for example, created through Chaos Center, which is like a portal that helps us see our workflow, observe it, and monitor it, and even create our workflow from the Chaos Center. We can see it. We will see it in the demo lately. How is that? So how is the chaos engineering is easy with Litmus and Jenkins? So to do that, we are going to begin from our to present the infrastructure, which is based on AWS EKS. It has been cooked via Terraform for the sake of demo. As chaos engineering requirements, we all know that we have deployed and configured the monitoring stack composed from Grafana and Prometheus, and also we have configured Slack to get notified with the necessary actions and also to communicate before executing chaos because it's very important. I'm trying always to insist that the communication is very and highly important keys of the chaos engineering discipline. We have also configured Jenkins GitHub to be triggered via pull requests, and also we have like a container registry like Git Docker Hub or Artifactory, for example. So here the developer will update its code or the app code and will push or create a pull request that will trigger the pipeline. And this pipeline, it will notify Slack that the pipeline has been started, and it's going to prepare the amp and then build the application and push it to dev. So here it will push to the Docker Hub container registry. Then we will start the QA tests. So I'm not going to present the QA test because it's not very important for the sake of our demo and our presentation. And then it will go to update the deployed app image. So it will be updated by the new application or the new image, and then it's going to inject chaos. So injecting chaos, it will be done via applying the workflow that we have already talked about. It's like a CRD, Kubernetes CRD, that will be applied. So here we will face two results: pass or fail. If it fail, it means that a chaos experiment fail, our app is not resilient, so it will get notified by Slack. Or if it pass, so our app resilient, so it will be promoted to production, tagged and promoted to production, pushed to the container registry with a prod tag. Then we will clean up the resources that has been created with the chaos workflow, for example, the chaos workflow, and also we'll clean up the chaos results, which is like a CRD for Litmus, and then it will notify Slack with the QA tests and the chaos, such as a chaos report. Now we are going to move to the amazing part, which is the demo. So get ready for it. So to begin with, I will present the code, which is like a simple, very simple code. Let's see together. LitmusChaos workflow up. It's very simple code. Our app, it's running. It's like doing hello chaos folks. So here, hello folks, for example. Here, hello folks. I will be updated it. And then we have our app, which is in here. Sorry. Yes, it's here. So here we have our app, which is here the Docker file of the app. It's like a Apache app, PHP app. And also we have the Jenkins file for pipeline. We have the prepare env stage, We have configured the build image and pushed the dev, the QA test, and also the update of the app, the deployment. Our app is like deployed in deployment, and then the chaos injection, jump via a script and work that contains workflow. And if everything goes fine, we will promote the app. The manifest of the deployment, which is here for the app, and we have different scripts. This is the chaos.sh and the cleanup.sh. The chaos.sh, it will apply the workflow, which is here, for example, the CPU Hugging workflow, and the cleanup, it will clean up the workflow that has been created, and also the chaos result, which reflect the which we will get where we can get the reports that has been sent to Slack. In the workflow, we can find 3 steps: install chaos experiment, CPU Hugging, which is the experimentation that we are going to running, and revert chaos in order to delete the runners and the agents that has been the runners and the resources that has been created through this via this workflow. In order to target our app, we have to update the app info, which is here. So in the engine, of course, in the chaos engine resource, here, for example, we are going to target the app namespace, which is app, with the app label, which is app chaos -demo, and the app kind is like a deployment. And for the CPU Hugging, we are going to do that for 60 seconds chaos duration, and we're going to target 1 CPU core, and this will trigger the chaos workflow. And this is, of course, the revert part. If you don't need to revert, we can delete this part. It will keep the different runners app to see logs, for example. We have also, for example, memory Hugging. We have the pod delete experimentation, for example, to delete pods randomly. The memory for deployment, for example. Okay. So for the workflow, here we have seen that the workflow is like an AIC code. You can also get it from the Chaos Center. So here, for example, we have the LitmusChaos Chaos Center, where we can see the different workflows that has been run. The Chaos Engine, which connect the cluster, the Chaos Hub also that contains Mary experiments in Azure, AWS, etc. We have the observability part. So here we are going to use our hours, which is Grafana, for example. And also we have other stuff. So here we can we can use team management, user management, and also we can integrate it to GitHubs. So for example, if I create like a workflow here, it will be pushed directly to the GitHub repository. So how can I, here the question, how can I get this CPU Hugging workflow? I can do it, it's very easy. So here from the Chaos Center, I will create a new one. For example, I will call it Conf42. Next, I will add, for example, like a pod CPU Hugging. Thank you. So here I'm going to like this. I'm going to target the app namespace, while the kind is deployment, and the app label, which is Chaos Carnival. So I can also define the steady state, like a probe that define if I would like to define the steady state of the app. It's very important. So for the sake of demo, we are not going to use it. So we can use HTTP, CMD, PROM, etc. And also for the tune experiment, we can do, for example, I'm going to go for a 60-second chaos duration and 1 CPU core. Click finish. For me, here for the reliability score, it's like for me the CPU Hugging is very important, so I will give it 10. If it's not important, for example, I can give it 6, or even I can give it from 0 to 3. For example, I will give it 10. And I will schedule it now. If I can schedule it now I will get view YAML. I can get this YAML and copy paste it in the VS Code and push it to our GitHub repo. So here, for example, I have already, for example, create a pull request which called trigger chaos conf. This chaos conf has prepared the env for me, build image and push it to dev, and has done the QS tests and then updated the app. So in the beginning, we have received like a notification saying that the chaos conf has been the pipeline has been started. Then it will at the end, at this phase, after the cleanup, we will get result like you will get notification saying that the chaos result that the pipeline has succeeded, and the chaos result with the experiment name, which is pod CPU Hogan exec, with the verdict pass and the resilience score 100, which is it means that our app is fully resilient and it's like doing great. Here, for example, I will update the app. Well, I will do hello case walk from around the world, and I will push it. Git add, git commit, git push origin So here it will trigger the app. It will trigger the master here, for example. The master will be triggered, it's pending, and then we will get like a notification here saying that it is started. Up, waiting for it. To get started. Up. It's like waiting for it, waiting in the queue. And here we have the started. Then it will inject the chaos, and we will go to all the way to the different steps that has been shown here. Up, all the way that here the QA test, and then updating the app. Here it will update the app. Here it has injected the chaos, and we will wait for the chaos to finish. When the chaos will finish, we will see that the app it will be updated, and we will see the CPU hogging. For that, for example, we can see that there are several resources that are created in the Litmus namespace, for example, which for example, they are the runners. They are the runners, for example, see here, runners that will execute the experiment, which is the pod CPU Hogan. Once it's finished, it will create for us the chaos results. You see it's chaos result that will be updated with the chaos, our chaos with the verdict and the reliability score. And also we have the workflow resources that will be created, which will be in running state, that will run our experiment. Which will run our experiment in the Litmus namespace. Here the chaos is waiting for chaos to finish, and certainly it has finished through the master. So if we can take a look to the Slack notification, we will get notified that it has been updated with the new image. It's like it takes sometimes to get notified. It's like a connection issue. Up. Well, we will wait for it to finish. and then we will get like the case results, experiment name, CPU Hogan, etc. Might take some time to get notified. Well, going back to our it finished. Let's see. Succeeded, so it's like notification error, so it's like the internet connection is lagging. So if you are good, we will see that the promotion, yes, it's like the internet has already finished. So normally it's updated, so it's right, it's updated, and here normally we'll get the experiment name with the result and the report. Going back to our presentation, I hope that you enjoyed the demo. So as we have seen that starting chaos injection is a must in order to improve our app resilience, and also we have before chaos injection we have always communicate what we are going to do, and it's very important for the sake of other team and the work of and in order to improve the in order to keep everyone posted that there will be like a downtime or something like that. And also we have also to make chaos more and more automated via, for example, as we have seen, Jenkins or other tools in order to improve it and improve it continuously. And also we have to keep enhancing one of the most requirement of the chaos engineering, which is the alerting systems, in order to get notified when we have errors, incident, and also we have also to keep enhancing the monitoring systems. And also all of that will reveal a lot of failures, and it will expose many things that we have already forgotten, or we didn't have the chance to take it into account in our infrastructure or our system. So we don't have to be afraid of, and we don't we have to keep moving forward. And also I believe that to key success we need to hack failure before. It's very important to learn from our failures. I hope you enjoyed it, and I would like to thank you very much for attending this session, and see you soon. Bye.